All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about feed-forward neural networks in PyTorch through Gemini. Now, before we begin, um, I want to talk about an idea that I had uh, yesterday, I think. I don't remember if I mentioned it on stream. Actually, I think I got the idea after finishing the stream. I think so. I think I got the idea after finishing the stream. Oh shit. We are at the beginning of the stream and we're already having um, dropped frame issues. Wait, give me a second here. Okay, all right. Um, right, so hopefully um, the drop frames issues will go away and we will be fine. Okay, so that was like a minor hitch at the beginning of the stream, I guess. But yeah, the idea that I had yesterday. So I've mentioned before that I wanted to um, practice and get better at Lua for two reasons. One was definitely for being able to configure NeoVim and install plugins into NeoVim and configure the plugins as well in NeoVim if I ever need to. That would involve two things. One, understanding NeoVim's settings system and their plugin system, and and two, it would involve learning Lua. Like I would need to know the language. So wait, I was saying there were two reasons why I wanted to learn, and then within the first reason, which was NeoVim, there were two things. One one was, I would have to learn all about how exactly NeoVim uses Lua um, for its scripting stuff, and then two, I would also have to learn Lua itself, right? So that's the NeoVim side. That's the first thing that I would be using Lua for. And the second thing was just in general, I wanted to learn Lua in case I wanted to, in case I ever needed to like embed it into some other application or something. So far, I don't, well, okay, up until yesterday, I didn't have any such use case in mind. Sorry, give me a second here. Okay. Up until yesterday, I didn't have any such use case in mind. And because of that, I was kind of concerned that I wouldn't be getting enough Lua practice. And, maybe 2, 3 months down the line, I'll just forget. I'll learn it now and then I'll just forget it because I'm not using it. Right. And because of that, I was trying to find excuses to use Lua. And one of the excuses that I found was Love 2D and and after that also Solar 2D. And I was going to be like, okay, I'll use this to practice Lua and I'll also get some game development done with it. But then yesterday I got the idea that, hey, the way NeoVim can be configured using Lua, what if I tried configuring my own VTuber application? Because I do plan on working on my VTuber application in Rust. So I was like, okay, what if I was able to embed Lua into my Rust application and then I could use Lua to configure my own Rust application or script functionality much more easily into the into the Rust application rather than having to, recompile the entire program from scratch each time. So what if I made certain things configurable through Lua and then compile the entire program. And then I would just need to, write Lua scripts in order to control various aspects. And there's quite a lot that I can make controllable through Lua. In fact, what I was doing previously, the thing with like virtual Stream Deck and stuff, I could technically do that as well. I actually intend on doing something similar, but well, more in terms of controlling the application. That's in terms of, controlling the application is how similar I want to do things. Um, so I was like, okay, let me check if there's a Rust crate for embedding Lua, because I remember doing some research. I don't know, 2 3 months back maybe, and I did find information. I didn't look too deep into it because I myself didn't know too much about Lua at that point. I know a lot more about Lua now, and so I was like, okay, I'm I can kind of kill two birds with one stone with this approach, because I'm trying to get better at Rust, right? And I'll be designing my VTuber application in Nano to get better at Rust and to also, build the VTuber application. So I'm going to get better at Rust by designing this application. But at the same time, I can also get better at Lua by embedding Lua into this program and actively using Lua to configure the program. Like, there's a bunch of stuff that I can do. Imagine, like, imagine writing entire settings files in just in Lua. Because previously, what I was going to do is I was going to look into Toml and then have a settings file saved, and within that settings file, there'll be, well, settings in a specific format. And now I'm like, hold on, if I have Lua available, why don't I just do something similar to what NeoVim is doing? Because like you can define key maps, you can define various settings, you can define functionality, you can do a whole lot of customization in NeoVim thanks to Lua. Lua is like it's basically an well, it's when you're embedding Lua, you're embedding the entire, like, scripting, uh the entire, like, what am I trying to say here? You're embedding Lua. Lua is a programming language with a certain set of capabilities. So when you embed Lua into your application, you get all of those capabilities. You get a set of tools that you can put together and use in various ways. And yeah, so I plan on using that approach. I'm going to be, instead of going down the Love 2D route and the Solar 2D route, what I'm going to do is I'm going to create an application, and I'm going to use the mLua crate because that seems to be the most widely preferred one right now, and also being actively developed. That's also something very important to me. I'm going to use that crate. And initially, I think I'll build a simple, because I'm also trying to learn Ratatouille. So initially, I think I'll build a simple, or you know what? I'm currently also learning Nano. So I could build, I could embed a Lua runtime into either of these, and I could practice it in that way. Because I wanna there's a bunch of different things that I want to be able to do. Because like with the mLua crate, it allows interoperability between Lua and Rust in multiple ways. It's not just from Lua to Rust. It can also be from Lust. Wow, from Rust to Lua. So maybe if you've defined Lua functions, you can call them from within Rust. You can pass entire variables, entire tables. I believe you can also read entire variables, entire tables. There's like it's like a two-way communication is possible. So or I should say both ways communication is possible. I don't know if the communication happens like in both directions at the same time, so I don't want to put that information out there, but it is possible to communicate in both directions. And yeah, that's my idea um, for getting better at Lua. And this has me excited because this is going to introduce like whole new possibilities. I'm introducing scripting possibilities, scripting ability into my VTuber application. I still want to do the cargo Tamil thing. I actually hold on. I'm curious about this, so I think I'll start up a Gemini instance. I was also having a conversation with Gemini about something else yesterday. Um, just a second. Yeah, I don't think I need to export this whole thing because we need to get back to our deep learning thing. And if I start exporting this, then I'm going to be sitting and reading the conversation out loud, and it's going to be taking time away from what we are supposed to be doing. Um, I believe I'm still using this one. Yeah. Can't wait. That's the Tokyo conversation, right? Yeah. Learning Tokyo. That's the Tokyo conversation. That's the Tokyo course actually that Gemini set up. Now I have to work within the limitations of Gemini. Fortunately, um, I don't run out of it like often, but like when I do run out, then it's like, okay, I'm stuck here. I can't continue the conversation here. However, um, I'm only stuck with I'm only stuck when it comes to um, making API calls. I'm not stuck when it comes to using Gemini, the Gemini web interface. So I could very easily just open up gemini.google.com, and on there um, I can start up whatever conversation. And in fact, it'll be faster to do it there because I have been actually having conversations on there because of the um, just a second because of the API because of the whole like exhausting the quota thing because they've turned the usage limits down at least for the time being because they seem to be getting or well their services seem to be getting overwhelmed with requests and that's probably why they had to turn it down. I'm hoping it I'm hoping they'll turn it back up eventually, but for now it's low and we have to kind of be economical in our usage. Now, before I forget, what's the question that I was going to ask Gemini? There was a question that I was going to ask Gemini before we. Oh, yeah. Um, Actually, this question is so simple that I'm not sure if I should be wasting and I should be wasting any of my API quota here. The only thing that's gonna help here is, or the only benefit here is that you guys will be able to see this conversation on stream, but then I don't want to exhaust the quota on something that's not necessary. So here's what I'm gonna do, okay? Because we do need to use the quota for this, which is our feed forward neural network course. So what I'm gonna do is I'm gonna open up the Gemini web interface, and there I'll ask the question. Okay, what's the question? Hey, so I know Tamil is a big thing within the Rust ecosystem. I don't know much about the language and plan on learning about it eventually so I can set up Tamil files for various things in my own Rust projects. What I'm wondering is, um, how do I go about serializing? I think this might point me towards the CRD crate, because I think CRD does the abstraction kind of thing. I haven't looked into it, so I could be wrong about this, but if I'm not wrong, or I shouldn't say if I'm not wrong, if my guess is correct, I'm guessing CRD is it provides like it provides an abstraction layer, and there's multiple backends supported, because this seems to be the very rustic way of doing things, where they'll set up an abstraction layer, and then you can implement as many backends as you want, and this way you have one fixed API that is using all of those other um, that is using all of the other backends. Okay, what I'm wondering is, how do I go about serializing and deserializing? Um, Hold on. Deserializing um, data to and from Toml. Is there an official Toml crate, or am I using something like CRD, which is another crate that I'm yet to look into? Okay, that's a great question. You're hitting on a fundamental part of working with data in the Rust ecosystem. You're correct that the TOML you're correct that TOML is the configuration format of choice for Rust projects. For example, the cargo.toml file. And CRD is the standard way to handle serialization and deserialization in Rust. Here's a breakdown of how you handle TOML serialization and deserialization in Rust. The key players, CRD and TOML. Okay, so these are two crates that I'm going to need. Um, Actually, no, maybe TOML is not a separate crate. Maybe TOML is just a separate backend, or maybe TOML is a separate crate, but that crate provides the backend for CRD to use. Okay, you will use two main crates to achieve this. CRD, um, this is the framework. It's a powerful generic mechanism for converting Rust data structures like structs and enums into and out of data formats. CRD handles this conversion logic. Then TOML. This is the TOML specific implementation of the CRD framework. It takes the general CRD instructions and applies them to the TOML format. Okay, setting up your project. To use them, you must add these two crates as dependencies in your own cargo TOML file. I think I want to do this today. Not on stream though. On stream, we're probably gonna continue with the feed-forward neural network, but I do wanna attempt this, because now that I've kind of become more familiar with the Rust ecosystem, and I've explored a bunch of crates. Um, Now I'm kind of getting more comfortable with, just diving into different frameworks and different libraries and stuff. And so I kind of want to try this out. I don't think this is going to take too much time away from what I'm doing, mostly because now I actually understand what's going on. Okay, to use them, you must add these two crates as dependencies in your own cargo toml file. That's fine. I can use the CLI to do that. Um, CRD features derive. I need to read up on CRD to understand what derive does. I think derive is going to be one of the macros slash attributes that we're going to be adding above um, structs that need to be serialized or deserialized. Anyways, serialization. Rust data to TOML string. This is the process of converting. You know what? I probably should have asked this question in Gemini CLI, and you guys would have been able to see the entire conversation along with like the example code and stuff. But yeah, it is what it is. Um, right. This is the process of converting a Rust struct into a TOML formatted string that can be saved to a file. Okay, so in the example, it's showing the following code. It's showing code that creates a struct called config, and above that, we've added I forgot what you call these things. It's like a with a hashtag and square brackets. I forgot exactly what it's called. But yeah, we add that, and within that, we are doing derive serialize. And then there's another thing called database, which is there's another struct, I mean, called database, which also has that derive serialize. Then we create a config struct, okay, and within the config struct, we also create a database struct. So basically, we create the config thing. What is servers supposed to be? Servers is supposed to be a hash map, which is our dictionary. Okay, dude, I haven't worked with hash maps a whole lot. I need to kind of keep up my practice of working with hash maps as well because I worked with hash maps um, when I was doing the Rustlings course, which I need to continue with the Rustlings thing as well, dude. I never went back to Rustlings. I kind of forgot about that. These are like, for those of you who don't know, they're fun exercises. It's an entire application that you can install and run, and then you can side by side edit code. And once you save the code, there's going to be files that you have to open and edit. There's going to be files within the files that are problems being described. You have to solve those problems and then save the file. And then the Rustlings application is going to check. It's going to check your answer once it gets the result that it was looking for. You've passed that course, or you've completed that exercise, or however you want to say it. You've successfully completed that exercise, and you can move on to the next one. And they have this for various Rust topics. Like they have for like simple stuff like conditions and loops, to more complex stuff like structs and generics and I believe even traits. And of course there's functions and closures, and all the different Rust concepts get covered in that in some way, shape, or form. I don't know about like the much more advanced concepts, but definitely beginner to intermediate, they do cover in that. By the time you're done with that, you should be fairly comfortable with using Rust, mostly because you will have used Rust quite a lot by that point, because you will have run into problems that you're trying to solve. Anyways, um, right. So then toml.string, toml.toString, and that's it. Okay, so the basic idea is that you create a struct, you add this attribute on top. I forgot what the thing is called. Hold on. Um, what what is the so and so thing called in Rust? That's an excellent question. Oh, it's an attribute. Okay, it's an attribute. So you have to add that derive serialize attribute above the struct, and then you create an instance of that struct, and you then use toml.toString and wait just a second. Yeah, you then use toml.toString and you're good to go. It's that simple. Holy shit, it is that simple. Well, with toml.toString, you have to use because it returns it. I believe it returns a result. So you have to put it into a match statement or some equivalent. I think you can do. I think if let might work for this. Yeah, I think if let sum might work. So in that case, only if actually no, if let okay, because like I've done if let sum for option, because with option you have sum and none, with result you have okay and error. I think if let does work for this as well, because It's something that you would be using in a match block. Okay, okay, dude, enough Rust stuff. I'm gonna I'm gonna look into the CRD thing, and I'm excited for that because now we are also exploring CRD, which I wanted to look into for a while. I remember initially when I was learning Rust, I was like, let me learn how to do serialization and deserialization. And I remember looking into CRD and just being completely lost. Because, dude, doing stuff in the Rust ecosystem is very different from, actually, I mean, to be fair, in every programming language's ecosystem, things are going to be very different. And it was definitely different in Rust. So, like, each time I would open up a new crate, look at its documentation and stuff, I would be lost because I wasn't used to the rustic way of doing things. And now I'm getting a lot more used to it because I've seen a bunch of other crates and how people implement functionality and how you, as a developer, are expected to implement functionality. So, yeah, I'm excited to get into this. Now, yesterday, I had asked Gemini this question. I think I asked this question off stream. Yeah, I don't think I asked it on stream. So let me read out what the prompt was. Let me also just make sure that you guys can see what. Yeah, okay. All right. Uh, Wait just a minute. Okay, so um, this was my prompt. This was when I was. This was after I did that whole, the autograd thing, and I printed out the gradients and stuff. So then I was curious about this because I had mentioned that I'm going to ask this question to Gemini later on because I do want to get an understanding of the math um, behind calculating the gradients and also then applying those gradients to the weights to update the weights. Like I want to understand how both of these things are working, generating the gradients and also using gradient descent to update the weights. However, I don't want to get into the calculus portion of it because that's going to then require me to learn some concepts of calculus that I don't know, and then I'm going to end up kind of going down the calculus rabbit hole and wasting a lot of time. That's not to say that learning calculus would be a waste of time. It's just that I would much rather spend my time, you know, making progress with neural networks rather than learning basic calculus. Wait, just a second. How are we doing on frames? Because I think it's my Twitch app that's crashing. I don't think we're dropping frames all that much. Yeah, we haven't dropped frames since the initial thing, when we initially dropped frames. Um, just a second. Let me just reload it, and we are good to go. Right. So, um, yeah. So, like I was saying, I don't want to dive into the math behind it, but I do want to understand the math. I don't want to learn how to implement the math. I should say that, but I do want to understand the math behind it. I want to get a conceptual understanding of it, a high level understanding, so at least I can um, well, for one thing, I want to be able to understand it, but at the same time, if I'm ever explaining to someone else who doesn't know how back propagation works and how exactly weights are being updated and stuff like that, I would then be able to explain it to them um, in 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 a in a not so math kind of way. I don't even know what I just said. In a not so mathematics focused way. I would explain it to them in a I would give them a more conceptual overview, because this is something that I've learned when you are dealing with math, and the math you're the math that you're dealing with, it's to solve a certain problem that's on a higher level, right? Then learning how the math is implemented isn't that much of an um, isn't that much of an important it isn't that much of a what's the word priority. Yeah, learning how exactly the math is implemented isn't necessarily always high priority, um, especially if you're using that math for higher level stuff. Like a lot of the stuff that you're doing is higher level and using that math on a lower level, then just getting a conceptual understanding of what the math is doing is enough. Anyways, carrying on with this. So, I asked the question, or well, I gave this prompt. I said, okay, I'm done with whatever you had said to do. The results are just as you said. This is really interesting. You mentioned calculus. I never had a chance to learn calculus, so I wouldn't really understand the math behind backprop, that's backpropagation, and how that calculation. Wait, did I make a typo here? And how that would calculation and subsequent update process. Oh, I think I was saying, and how that calculation and subsequent update process works. I want to understand both of those things. Considering that there's already a system in place for this, I'm wondering if it's even necessary for me to learn the math behind it, unless I'm implementing it myself, or is just a high level conceptual understanding enough? Okay, Gemini said this. This is an absolutely brilliant question, and it gets to the heart of learning, modern deep learning. Okay, the short answer is no, you do not need to be an expert in calculus to start building and training neural networks. A high level conceptual understanding is enough to be very effective, especially when you're starting out. Frameworks like PyTorch are specifically designed to be powerful abstractions. They handle the complex calculus of backpropagation for you, so you can focus on designing the network's architecture, preparing the data, and training the model. You can become a very competent practitioner with just a solid conceptual grasp. However, and this is the longer answer, while you don't need to do the math by hand, understanding the concepts behind it becomes increasingly valuable as you progress. Here's why. One, for debugging. The most common reason to understand the math is for debugging. Sometimes your model won't learn, the loss might explode to nan, or stay flat. Understanding what a gradient is helps you diagnose these issues. For example, you might hear terms like vanishing gradients or exploding gradients. These are problems with the numbers being calculated during backpropagation, and knowing the concept helps you understand why changing an activation function or a network structure might fix it. Two, for making informed decisions. It helps you answer the why questions. Why choose one activation function over another? Why use this specific loss function? The answers are often rooted in how they behave mathematically and how that affects the gradients. Um, just a second. Three, for reading new research, if you ever want to read a new research paper and implement a cool state of the art model, the paper will be written in the language of math. Okay, my recommendation for you, for now, let's treat it exactly like you said. We have a reliable system in place, which is AutoGrad, and we will use it. Focus on the conceptual level. The loss function tells us how wrong the network is. Backpropagation is a process of what figuring out which direction to adjust each parameter to make the network less wrong. The gradient is the specific value that tells us the exact direction and magnitude of that adjustment for one parameter, and the optimizer is what actually takes the step and updates the parameter using that gradient. That's it. That's the conceptual understanding you need. As you get more comfortable, you might find yourself naturally wanting to peel back the layers, and at that point, exploring the math will feel like an exciting discovery rather than a chore. Okay, cool. With that settled, you have now covered all the topics for chapter 1. You've learned about tensors, how to create and manipulate them, um, and how PyTorch's AutoGrad system works conceptually. Are you ready for your first exercise? I think at this point I should I think at this point I should also save this conversation. So let's do chat save FCNN course, um, chapter 1. Or should I do that after the exercise? Maybe, yeah, you know what? We can do that after the exercise. Yes. Okay, now I'm hoping that, wait, okay, take your time with this exercise. When you're done, please share the output of your script. This will conclude chapter 1. Okay, let's take a look. Great. Here's your exercise for chapter 1. Tensor operations and gradients. Create tensors, perform operations, and use AutoGrad to calculate gradients. Create a new Python script, exercise 1. Um, import the torch library. Create two tensors, tensor x, tensor y, both with shape 2, 2. Initialize tensor x with so-and-so values, tensor y with so-and-so values. Crucially, ensure that requires grad equals true for both tensor x and y. Then perform the following operations. Calculate an element-wise product, and then calculate the sum of all elements in product tensor. Wait, calculate the sum of all elements. Oh, okay, there's a regular sum function. Okay, calculate the sum of all elements in product tensor. Okay. Sorry, zoned out. Okay, then call the dot backward method on total sum to compute the gradients. I think I need to understand how this is working. Like, so we call backward on total sum. I need Gemini to explain this bit to me. Because I understand that like in the back it's building this kind of graph and then calling calling backward helps it traverse that graph that it's built, and all of these items that were included in actually, the creation of this variable, all of their gradients are going to be mentioned. I wonder if product tensor would also have a gradient. Yeah, that would be interesting to look at. Okay, challenge optional. Think it through. No need to submit code. Can you manually verify what the values of tensor x.grad and tensor y.grad should be? Hint, if f equals x multiplied by y, then df dx. Okay, see, I don't know calculus, so I'm not sure how I would go about calculating that. I think d is supposed to be delta, which is supposed to tell us the change. So we are dividing the change in x. No, we are dividing the change in f by the change in x, and that gives us y. And then we divide the change in f by change in y, and that gives us x. When you sum multiple such products, the gradient will also sum up. Take your time with this exercise. When you're done, please share the output of your script. This will conclude chapter 1. All right, so uh, exercise 1.py. First thing we need to do is import torch. Then we want to actually, okay, import torch, and from torch import tensor. Right, tensor underscore x equals, I forgot, hold on. What did, having multiple screens definitely helps. Actually, um, this is thanks to having multiple screens and having a tmux based setup, because these multiple screens are all different machines. They are not all connected to the same machine, but I'm able to look at them. Um, I'm able to, well, I'm able to have the data from one machine on all three machines thanks to tmux. What was I doing? Yeah, okay. Tensor, initialize the tensor with so-and-so value. Right. So, um, 1, 2, 3, 4, and then 5, 6, 7, 8. All right. So 1.0. Actually, wait, back up. Yeah. 1.0, 2.0, then 3.0, 4.0, then just a second. Yeah, okay. Then this is supposed to be tensor y, 5, 6, 7, 8. That's done. Oh, one more thing. They need requires. Wait, why is that not showing up? Am I missing something here? Where exactly? No, we specified while initializing the hold on. Let me check something. Torch.tensor. Um, yeah, why is that not showing up? I'm curious. Okay, requires underscore grad equals true. Okay, and then requires underscore grad equals true. Let's save it. No overloads for this. Where are we supposed to specify this? Hold on, let me go back up here and see. Oh, that's Wait, that's interesting. So there's a difference between tensor with a capital T and tensor with a small t. In tensor with a capital T, actually tensor with a small t is a function, and that returns a tensor. So that's what I'm supposed to be using here, and that's why requires grad wasn't showing up. So I guess we can get rid of this. Yeah, and then let's just do small t and small t. Now we should be fine. Also, if I now do um, tensor dot so and so, and then in here I do requires grad, it shows up. Great. Okay. Let's go back down here and continue with the exercise. I don't think I can do this last bit. I do want to get the answer for this. I don't understand. You know what? We can try looking at the top. No, I'm gonna say, because I don't really know calculus, so I don't know how to calculate this thing. Because all I know is like, okay, we're calculating change in f and change in x. If f equals, if f equals x multiplied by y. So I've looked into calculus a little bit, and I did get to this changing part. F is supposed to be the function, and df is supposed to be the delta of that function, and then dx is supposed to be the delta of x, and the delta is supposed to represent a change over time. But like, how are we calculating that? Like, what was x's gradient to begin with before it changed? Also, how are we calculating? Oh, yeah, this is how we are calculating x and y. Yeah, yeah. I don't think I'm gonna get this. Let's do the other part of the exercise. Okay, product underscore tensor. This is supposed to be an element-wise. Yeah. So tensor x multiplied by tensor y. Then total sum equals product tensor dot sum. And then we call total sum dot backward, and print out x dot grad, which is x dot grad. Oh, it's not x dot grad, it's tensor x dot grad. Okay, then tensor y dot grad. Okay, let's quit this. Oh, I can't run it here. I need to run it here and change this to ex. Okay, so that is our gradient. Is that our gradient? Hold on. Yeah, that's the gradient. We called. Okay. What did Gemini say to do? Take your time with this. When you're done, please share the output of your script. I don't know if this is gonna, like, if I try to copy this, then, I mean, I could try this, and then, oh, okay. Yeah, that can work. That can work, but I'm curious about something, so I'm just going to do something real quick. Okay. What would happen if I did that? Okay, that works as well. I think I did the setting where um, because Tmux has a scroll back buffer. It has its own scroll back buffer implemented. So what you can do is you can hit Control B and then open square bracket, and that's going to go into this. I forgot what the mode is called, but essentially it's a scroll back buffer, and you can scroll, all the way back. And um, if you need to copy something, some of the text that's on screen, you can um, hit space, and then you can copy anything. So you'll notice the color changing. Is it changing on screen? Hold on. I think, yeah, it should be changing on screen. Yeah. Um, so once you've selected your text, you can then hit enter, and it's gonna store it in like the clipboard or whatever. Um, Hold on. Yeah, there we go. So this is what it copied. Um, Both of these are tmux, but if I paste from one to the other, now I need to switch again. Okay. Okay, I did that. Um, I did the exercise, and this is the output. Um, Hold on. Okay, copy that, save, and then go to the next thing here, and then come here and do that. Okay, that is our output. I do have some follow-up questions before we continue. And I wasn't able to do the extra bit. You know what? I'm done with this, right? So I can show the screen again. The extra bit that you added, because I don't really understand what df, um, dx, and dy are. However, I don't want to just skip it. I want you to help me um, get through it so I can hopefully learn something extra here. But yes, I do also have some follow-up questions. All right, give me a second, and well, give Gemini a second as well. Oh, okay, this is taking some time. I also noticed that we dropped some more frames on stream, unfortunately. Um, but fortunately, it was for a very short period of time, so we kind of also recovered. Dude, I'm excited, man. I'm excited to work on my VTubing application because now the entire thing is going to be in Rust, and I feel like having gone through multiple iterations of my VTuber app in the past, this time, this next iteration, because now I actually have some experience with building this stuff. Now I have experience with trying to implement stuff from scratch, And I also now have the knowledge that a bunch of things that I was trying to implement from scratch, there are already libraries and protocols that implement those. Well, no, there are already libraries that implement those things that I was trying to build from scratch. And I definitely plan on using a bunch of these things. Like, holy shit, there's so much stuff to look into. Um, it's crazy. Like, dude, for communication purposes, I could have looked into protobuf. That because that gives a nice structured way of doing things, and in the end, you end up with a binary message, which was what I was trying to do. That was something very important for me. Um, I was trying to end up with um, a binary blob essentially that can be sent over the network, right? So that was for actually packaging the data, packing and unpacking the data. Um, for the actual transport, I could have used a couple of other higher level things instead of implementing my own server, which I'm not complaining about because that the time that I spent doing that, it was a good learning experience for me. And would I do it again? No, definitely I would not try and implement a bare bones socket server with the I wouldn't spend time working on the lower level systems unless I absolutely had to, because those lower level systems have been implemented by somebody else already. And to be fair, I have already spent the time implementing my own, so I don't really feel the need to do it. I've spent my time learning. Let's just put it that way. For the actual like communication, I could use something like WebSockets, or I could use Redis or any other sort of protocol for the actual communication. For each of these protocols, there's already, libraries that have implemented the server and the client. So it's ready to use, right? And then there's a bunch of other stuff. Like each of these things that I tried to implement myself, now I can use other libraries to do it. And I feel like now I'll be able to do it in a much more optimized way, much more efficient way. And so I'll be able to focus on actually building the VTuber app itself rather than building the tech that powers the VTuber app. And I'm excited for that, dude. I'm so excited for that because there's so much stuff that I'm going to be implementing. I want to try doing something different in terms of my own VTuber model. Um, I want to try doing something. I want to try coming up with like different sorts of effects. Let me see. Let me see what I'm able to do. Yeah. Let me see what I'm able to do. Also, this time maybe I might be able to make the thing modular. So the world and the VTuber model aren't tightly coupled together. I'll have to see how to go about doing that though. Because it's not like I plan on changing models often. That's just not a thing that I do. In fact, if anything, once I build a model, it's just going to be like, that's me. That's me. This what you're seeing on screen right now. This has been me for the past couple of years now. At least for the past 2 years, it has been this, I believe. Yeah, I think so. I think so. At least for the past 2 years, this has been me. I So when I do build something, it's not going to be, though I want to make it in such a way that it's not very tightly coupled with the main application logic. That way, if I do want to make changes or completely remove it, it shouldn't be that much of a headache and it shouldn't break things. So I need to be sure to design the app in that way. And there's a bit of brainstorming that I have to do. Anyways, let's oh, rate of change. That's what it is. Okay. Well, okay, delta is the rate of change. Right. Okay. So, wait, let's go from the beginning. Oh, there's more here. Okay. Excellent work. Your output is perfectly correct. Okay. This shows you've successfully set up the tensors, performed the operations, and used AutoGrad to calculate the gradients. Where was I? Yeah. Used AutoGrad to calculate the gradients. And that is a fantastic question to ask. Let's tackle it right now. Skipping it would be a missed opportunity and it's less complicated than it looks. That's reassuring. Okay. Demystifying so and so. First, let's talk about the notation. When you see this, you can read it as the rate of change of x. No, the rate of change. Oh, it's not divided. Okay, holy shit. I don't know. I don't know what I was remembering this entire time. When I was saying delta of f divided by delta of x, I don't remember what I was remembering there. Because like this d thing, it also gets written as, at least from what I'm remembering, it also gets written as a triangle, and the triangle is delta, and delta represents change. Um, I don't know. Anyways, right. So first, let's talk about the notation. When you see so and so, you can read it as the rate of change of f with respect to x. Think of it like this. If we have a function f that depends on a variable x, then so and so answers the question, if I nudge x by a tiny amount, how much does f change? Okay, it's a measure of the influence of x. It's the measure of the influence that x has on f. All right. Think of it like, wait, I think I'm done reading that. Okay, yeah. In our exercise, f is our final single value total sum. X is our first input and y is our second input. So when we look at tensor x dot grad, we are looking at PyTorch's calculation for df divided by dx. Okay, it tells us the influence that each element in the tensor has on the final total sum, had on the final total sum. Okay, let's do the manual verification. Let's write out the math for total sum. Okay, that's so we do our element wise multiplication and then we sum up all of those numbers. Okay, now let's look at the gradient of tensor x. We want to find the influence of each of its elements on the final sum. Consider the top left element of tensor x, value 1. How did it contribute to the final sum? It was multiplied by the top left element of tensor y. Oh yeah, true. That's a element-wise multiplication. The other elements of tensor x, like 2, 3, and 4, have no interaction with it. So the rate of change of total sum with respect to this element is simply its partner from tensor y, which is 5. Consider the top right element. Its influence on the final sum is determined by what it what it was multiplied by. The top right element of tensor y. Sorry, zoned out. Okay. Um, Determined by what it was multiplied by, which is 6. Bottom left is 7, bottom right is 8. If we assemble these gradients into a tensor, which is, if we assemble these gradients into a tensor with the same shape as tensor x, what do we get? Yeah, we get that. Look familiar? It's exactly tensor y, um, and it's exactly what your script printed. By the same logic, the gradient for tensor y will be tensor x. So you've just manually performed the logic of backpropagation for this simple network. You've discovered that for an element-wise multiplication followed by a sum, the gradient of the output with respect to one input is simply the other input. You know what? Okay. All right. We're gonna go with this. I do still have doubts about this. I do want to explore this, but I feel like I don't want to go too much off track. Um, so I think I'll dig into this in a different conversation with Gemini. I'll do that separately, not here. Okay. Um, yeah. What were the follow-up questions? Okay, so I noticed that we called what was it called? Backward. We called backward on total underscore sum, called backward on total underscore sum, and that seems to have calculated gradients which then got stored in tensor y and tensor um, uh, tensor x and tensor y's grad fields. Help me understand the connection here and how this system is working. What I'm trying to do here is I'm trying to get um, Gemini to tell me about like the whole, computation graph that gets built. Now, while Gemini is generating this output, let me take a sip of my energy drink and also drink some water. Dude, holy shit, they must be having like massive load. Damn, this is crazy. If I were having this conversation through um actually, okay, to be fair, this could also be my own internet connection shitting itself, because of which It's taking some time to respond, but I believe this is also because of Gemini itself. Um, More specifically, when you are interacting with Gemini through an API, I think they're like throttling the bandwidth again, probably because they're under like massive load right now. I am interested in what's going on. Like I want to find out what's going on there. I should do some research on this after the stream to understand like what exactly is going on, because they turned the rates down, the usage. They turned the rate limit. They turned the rate limit down, meaning you are able to make even lesser API calls now. Not only that, now the responses are also taking time. I'm not complaining. It'll take however long it takes, but something is going on. Okay, I think we are getting the I think we are getting the response, because it mentions here explaining Autograd's code. You know what? While this is doing its thing, I could talk about the Lua conversation that I was having with Gemini. Um, so I can take it from the top. Um, what did I say to Gemini? So this was a long prompt that I'd given. Just a second. Let me have the thing open here so that, yeah, okay. Okay, so I'd given a prompt. I said, "Hey, so I'm planning on working on a sort of VTuber app for my stream. I'm planning on using Rust, Nano, and a bunch of other crates. Here's the thing. I learned about Lua recently, or I've learned about Lua recently and realized that it's incredibly powerful as an embedded language to create custom behavior without having to hard code that into the app and recompile the app. What I'm wondering is, um, how how would I go about adding functionality to my app to where I could allow Lua scripts to be written? Oh, there's our response. Okay, I'm gonna just finish reading out the prompt. To where I could allow Lua scripts to be written, loaded, and run by the app. Like, what's the workflow there? Pretty sure I don't need to provide an interpreter, though having a tiny simple one. Actually, in this case, what I meant wasn't that when I said that I'm pretty sure I don't need to provide an interpreter, I meant like a REPL. That's what I should have said. Pretty sure I don't need to provide a REPL. The script does need to be interpreted by something. In this case, it's a Lua VM that the script gets executed in. I think I could have chosen, better words there, but anyways, though having a tiny simple one in the app would be super cool for controlling one-off things. But yeah, like, where do I begin? Where do I even begin with this? Explain the working parts to me. And then Gemini gave me the whole rundown of the various parts that would be involved. It mentioned that, okay, you have the Rust Lua bindings provided by mLua. Then you have the Rust side itself, where you'll be programming the stuff that's going to be running the app, and then you have the Lua side, or rather the Lua VM that's going to be running within your Rust app, and then there's also the whole loading of scripts and stuff. Okay. Anyways, now that this response has arrived from Gemini, let me read this. Of course, this is the most critical concept in AutoGrad, so let's zoom in on it. The connection is a hidden data structure that PyTorch builds for you called the dynamic computation graph. Think of it like a family tree, but for your tensor operations. Building the graph, the forward pass. As soon as you create a tensor with requires grad equals true, you're telling PyTorch keep an eye on this one and anything that comes from it. When when you perform an operation, PyTorch creates a new node in this graph. Let's trace your exercise. Okay. You create tensor X and tensor Y. These are leaf nodes or the ancestors of our family tree. They have no parents. Okay. You create product tensor. Okay, that's the result of the element-wise multiplication. PyTorch creates a new node for product tensor. This node, I love that Gemini is able to present graphs and flowcharts in like a terminal or ASCII art kind of format format. Because this isn't the first time that Gemini has done this. There was another time where it was explaining with like nodes that were like squares and that get connected to each other. So it was like I think it was a undirected graph where you had like two or three nodes and they were connected to each other. And Gemini managed to show that connection through through ASCII art in the terminal itself. Um, where was I? Okay, yeah. PyTorch creates a new node for product tensor. This node knows two things: its inputs and the function that created it. That's a multiplication function. Okay. You create total sum equals product tensor dot sum. Again, PyTorch creates a new final node. This node knows its input, which is product tensor, and the function that created it, which is a summation function. This all happens automatically during the forward pass, your regular code execution. The final result, total sum, is the root of our graph. Traversing the graph, the backward pass. Okay. Sorry, zoned out. Okay. Traversing the graph, the backward pass. Now, now for the main event. When you call dot backward on a tensor, you are telling PyTorch, dude, hold on, hold on. I wonder, this just occurred to me. Holy shit. I wonder if there's a way that I can export this graph in dot format so I can then visualize it. Holy shit, dude. Dude, no, that's crazy. Hold on. I need to be able to visualize this. I wonder if that's possible because there is something to do with PyTorch and I think Onyx and GraphViz that makes it possible to export a graph, but that was for neural networks specifically. I don't know if they do the same thing for this computational graph, but if the computational graph looks like this, I mean, I'm sure this is probably a simplified overview of it, just for my benefit because I don't know too much about the complex system that's being implemented here, but even getting like a simple conceptual overview like this in graph form would be useful. It would be helpful. Dude, I can use that. I can definitely use that. Yeah, that should be my next question. Okay, traversing. Now for the main event, when you call so-and-so, you are telling PyTorch, start at this node and walk backwards down the family tree, calculating the gradients at every step. This can only be called on a scalar that is a single value tensor like total sum because it represents the single final error or loss that we want to measure everything against. You can call total sum dot backward. No, not can. You call total sum dot backward. Then PyTorch starts at total sum. Um, it um, it asks the node, how were you created? The node answers by a summation function acting on product tensor. Okay, PyTorch knows the derivative for a sum operation. It calculates the gradient and passes it back to the product tensor. Now PyTorch is at the product tensor. Wait, hold on. I wasn't visualizing this as I was reading it. PyTorch starts at total sum. It asks the node, how were you created? The node answers by so and so, acting on so and so. PyTorch knows the derivative for a sum operation. It calculates the gradient and passes it back to product tensor. Now product tensor? No. Now PyTorch is at the product tensor node. It asks, how were you created? The node answers by a multiplication function acting on tensor x and tensor y. PyTorch knows the derivative for a multiplication operation. This is the rule we discussed in the challenge. The gradient with respect to one input is the other input. Okay. It calculates the gradients and passes them um, back to both tensor x and tensor y. Then PyTorch arrives at tensor x and tensor y. They are the leaf nodes. They have no parents in the graph, and they have no parents in the graph. When the backward pass reaches a leaf node, it accumulates the gradient it just calculated into the tensor's special dot grad field. So total sum dot backward is the trigger that initiates a journey from the final output through all the intermediate steps back to the original input, calculating the influence at each stage and depositing the final results in the grad fields of the tensors that started it all. Oh, so does this mean that, wait, let me test this out myself. Does this mean that product tensor would not have, um, wait, so let's do this. Um, product tensor dot grad, and then we can do it here, I guess, or here. Yeah, let's run this. Okay. User warning. The grad attribute of a tensor that is not a leaf tensor is being accessed. Its dot grad attribute won't be populated during autograd dot backward. If you indeed want the grad field to be populated for a non-leaf tensor, oh, so it only populates the gradient field or the grad field for whatever is at the end of the graph. Like you start from one end, but like you go all the way to the beginning, which is what they call the leaves. Okay, the leaves, the leaf nodes, let's say. Yeah. All right. Cool. What was I? There was something else I was gonna ask. Okay. Hey, this has me wondering, is there a way to visualize this computation graph at any step, like perhaps um, any function that can export this as a dot graph that can then be rendered using the dot CLI. Damn, we didn't make as much progress as I thought we would. Though to be fair, we did look into quite a bit of this. We did look into the backpropagation aspect of PyTorch, and we tried to understand it, or rather the autograd. We looked into autograd and tried to understand it, so that's something. Okay, um, that's a fantastic question, and one that many people ask when delving into autograd. Visualizing the computation graph is incredibly helpful for understanding how gradients flow. Yes, there is a very good way to visualize the computation graph, often exported as a dot graph. Holy shit. Okay, this changes things, dude. I didn't know this before. Okay, while PyTorch itself doesn't have a built-in two dot method directly on tensors, there's a popular external library called TorchViz that does exactly what you're asking for. It uses the GraphViz library, which can render dot files under the hood. Okay, so you install TorchViz and GraphViz. You'll need to install both TorchViz and GraphViz system pack and the GraphViz system package. So I have GraphViz installed already. I probably need to install TorchViz on this um, in this project. I'm assuming TorchViz is because it's a library, right? Yeah. Pip install TorchViz. Um, Please activate your virtual environment first and then install. Okay. Right. I've installed GraphViz already. I don't remember if I installed it here on this system, but wait, I can check right now. Um, nope. I don't think I have it installed. Though, I mean, installing it shouldn't take time. I can install it quick. I just need to look into the installation instructions, and I need to see what's a good way to get the most up-to-date version, because sometimes it happens that the version that's in like the Ubuntu package repo, Ubuntu distribution, whatever you call that thing. Um, Sometimes they have like older versions. They don't always have the most up-to-date versions. So I need to see how I want to go about that. Okay, so use TorchViz in your Python script. Now let's modify exercise and okay. Now, you know what? We can generate the code and I can at the very least look at the code. Tensor grad, okay. Make dot. Make dot is from TorchViz. Oh, I believe TorchViz is what I had come across when I was trying to find ways to visualize a network, a neural network. And one of the suggestions, among many others, was using TorchViz, because TorchViz can do like a lot. Okay, visualize a computation graph. Parameters so and so, so and so. Dot takes the output tensor and optionally a directory of parameters. You can You can provide names for your input tensors for clearer visualization. Okay, okay, hold on. This will save. Oh, it does the rendering for you as well. That's crazy. That's crazy. I'm assuming it internally it might be using GraphViz's tools, in this case either dot or something else, in order to do the rendering. So internally it might be calling whatever programs are necessary for doing the compilation or doing the rendering. Okay, what to expect? When you run this script, a PDF file named computationgraph.pdf should be generated in your current directory and possibly opened automatically. In this PDF, you will see nodes. There, these represent your tensors and the operations, then edges. These show the data flow. Yeah, okay, okay, all right. Yeah, I've seen what that looks like. Um, okay, all right. They essentially trace the grad FN connections we talked about. This visualization will show you exactly how the AutoGrad engine connects the output total sum back to the inputs through the operations. Go ahead, install so and so. All right. Okay, that's awesome. We'll look into that later. Yeah. For now, would you mind explaining to me again what am I trying to understand here? Oh, to me again, or um, perhaps even giving me a conceptual understanding of what is happening in backward, what concepts are being utilized, and maybe a bit of an idea of the math being used, but don't go too deep into that because I don't know calculus. Okay, all right. Now, give me a second, okay, while this response is being generated. Wait, just a second. Okay, so I've seen this person live a couple of times before. Um, I don't know what they're doing, okay, but I'm seeing a couple of interesting buzzwords here. I'm seeing stuff like NASA, AI, space. Their title also mentions PhD dissertation defense. Um, I have no idea what they are doing, but we are gonna go hang out in their stream. I hope they don't have any settings that prevent one person raids. Fortunately, they're not like, follower only chat. Okay, their raid settings do not allow you to raid at this time. Never mind. So we're gonna go find somebody else then. Or I'm wondering if I should raid. Well, yeah, I mean, I might as well raid because, yeah. Um, Hold on just a second. Um, you know what? We'll go to this person because I've seen this person before. I hope there's no settings or anything preventing me from going there. Okay. We will go to this person. I hope they speak English. Because I believe they might be Japanese. I'm not sure. This target has disabled raids. Okay, dude. Fine. We cannot go there either. Holy shit. This is crazy. All right. I found another person here. Let's go to their thing. Actually, there's another person here as well. This person is doing coding. Yeah, they seem to be having a conversation with Gemini. They are a React Native developer building consumer mobile products with AI integrations. Wait, that's interesting. Hold on. They're doing AI stuff as well. Okay, cool. So let's go there. So this person's name is Zach, and yeah, yeah, they're doing stuff. So we're gonna go there and hang out for a bit. And yeah, that's gonna be it for today's stream. Um, Dude, once again, like I'm excited about this streak that we are on. Um, I've been streaming like for 2 weeks straight, as in I've had a stream every day for 2 weeks or more, maybe. I was uploading the VODs yesterday, and I was looking at the dates, and I've yeah, it's been from like I don't know the 20th of last month. Since then, I think it's been just constantly. But yeah, dude, I mean, I'm excited about that. We've got a good streak going, and even if I end up having to take like one day off, which I'm really trying not to do, even if I have like those low energy kind of days, I might just do a gaming stream, just like a chill, relaxed gaming stream, and that way I'll still be streaming on that day. But yeah, okay, okay. The raid timer is about to run out. So that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.